Okay, with all the assessments I did, well, the three assessments, a lot of circuit boards were made up. Here's the Philips D-class amplifier that I tried. Well, here's the first, and here's the first attempt I made. I had a few problems with it, like I realised I forgot to add a link there, that's what the blue wire's for, and couldn't get it to work. I was afraid there might have been an error in the actual circuit board transfer from the schematic to the circuit board PCB layout, so I did another one to be double certain using a totally different, fresh approach. This one I mounted the surface mount components all pretty much on one side, and the through hole on the other, and I made the pad holes larger for the through hole components. This here is one of my attempts at making up a device that could distinguish between two different frequencies, but I realised as I was populating it that there was actually a design flaw in the circuit design itself, and in the PCB. Here's a second attempt which also had the same design flaw in it. Here's some crystal lock deafened transmitters that I tried to get going that had some issues. This here is a half bridge driver. Now I was going to try and use this as well as the full bridge driver and compare them both, but never got around to it, and I was a bit worried there was some issues with the way I wired the D-class module as to where its ground would be relative to the signal. Here's a signal generator I used to trying to work out the best way to run the function generator chip. It's another one of them. It's another one of them. These here are some of my first attempts at making double-sided circuit boards. As you see, this was one of my early attempts where it didn't turn out too well. I found the solution to solve this problem would have been to scrub it lightly with a toothbrush while etching. That's most of it.